someone else, we are going to start our discussion today with Makerere, having completed highly output streams, elections, those are the modules and I see we have how are you?
So,
Yeah.
how many videos?
Yeah.
That's what the software is. Very students.
You need to install the
That's still between
Yeah, so we want to talk about learning, and you find that most processors nowadays use a scheme called preemptive multitasking or preemptive scheduling, where if a process is waiting for a resource, maybe it's waiting for to access a printer or it's waiting to access a hard disk, but it's waiting to open a connection to our web service. That wait time is not, the processor will not wait for that process to complete. It should put it in either blocked state or it suspends it for some time so that it can serve other processes or other tasks. So there are three things here. There is a process, there is a thread, and there is a task. We need to know what the difference of all those are, or what is their relationship. What's the relationship between a thread and a process, or between a process and a thread? The applications we've been making all along, the applications we've been developing, the ones we've been running, are single-threaded. They are single-threaded applications, meaning that only one thread have access to the entire memory in which that application has been located. And it also has access to all the processor time that that task has been allocated. So there's a difference between single-threaded and multi-threaded applications, as we are going to find out. Okay? So we want to be able to create threads. We want to create applications that can have different threads serving different functions at different times or at the same time. So threads generally are processor activities that run simultaneously. They run at the same time. Okay? Managing different tasks in the process. Alright? So a process is an area of memory that contains both data and code. And every process has a thread. Every application you run has a thread. If you go to your administrative tools in control panel, you will see so many processes. Those are the processes we are talking about. Every program has a process, be it a Windows service, be it a Windows application, be it a web application. They all have processes associated with them. So if you say you go here in processes, then you see all these processes are every process has a thread. So each one of these processes have threads associated with them. The username, CPU usage, and the memory they have been allocated to use. Every process has that. So in single-threaded applications, a process has one single That's why we are saying a thread is a scheduled execution of a process, and we could have made one process. So we could have many in one process. But to start with, there is always a single process. It's up to you now to divide it into several threads. Okay? So we take a look at this example on single thread applications. So this is how a single thread application would look like. You have a process, number one. Maybe it's an SQL server, maybe it is an application that you developed, and it's been allocated 120 MB. If it is a single thread, then the main thread, which is the thread associated with this process, will have access to all the memory that this application has been given. That is, if the process has been allocated 120 MB, the thread will also access 120 MB. This is for single thread applications. Now, if you go to multi-threaded applications, this is for entire memory space. The thread, when you start, you have a main thread. Then you start sub-threads. Continuous. You can have as many as you want. For example, in this case, we have a thread that accesses a database connection. We have another one that sends some work to the printer, and another thread trying to connect to a socket. Each of these, the 120 MB now will be divided to these threads. They match you depending on how many threads you created in your application. So if it was 120, then the main thread would be 50 MB. Thread number 1 would be 20 MB. Thread number 2 20 MB. Thread number 3 10 MB, and so forth, depending on how many threads you want to create. Now, something I need to mention is that each of these threads can access the main memory area independent of each other. So if we have a variable here in the main thread section, each of these sub-threads which we created can access those variables. And that comes with the issue of concurrency. How do we make sure that that variable is not accessed simultaneously by all the threads? Because one thread might want to modify the value, another thread might want to read the value. So how do you make sure that the access of that variable is synchronized? So that we do not have thread number 1 changing the value to 10 of that variable. At the same time, subthread number 2 wants to change the value to 20 at the same instant. So that comes with the issue of concurrency. How do we manage concurrencies of our threads so that thread number 1 can execute independent of thread number 2, but when it comes to accessing the global area, there is a synchronized access to variables and resources that reside in the main memory area. So the thing to note is that every application we have to have the main thread. That is what has to run first for you to create these others, the small threads, the sub-threads. Then they are given. So there is the main thread followed by the sub-threads that you can create and assign them different tasks. Okay. So for example, if you look at the situation of an ATM machine, there are many people connecting to the same server. Okay? Everyone is plotting in their card to withdraw or to confirm balance or to maybe deposit in some cases. There is only one server that serves those requests. So every request can come at once. And it will not be the server or even 100 sometimes, probably 1,000 requests can come at the same time. So how do you make sure that all these requests are served automatically at the same time without the request queuing so that they can wait for each other? So in the ATM situation, you have to create a thread for every request. When a request comes, you create a thread for it. You will serve it and send the reply to that machine. So every thread per request will have to be adopted. Okay? So this is very important in the understanding of threads. Of course, with this other one possible threaded applications in which you have only one thread, one process, the entire memory can be accessed by the thread, the main thread. But when it comes to this case, you have the memory to serve the various threads that have been created. And these threads can be got to this also at the same time. Okay? So how is it implemented in Java? That is the general concept of our case, because we've said due to the preemptive nature of current processors, tasks do not need to wait. Tasks do not need to, processor does not need to wait for a task to finish for it to serve another task. It can put a process in a blocked state, it can suspend it for some time, that is if it takes a long time to respond. Then it can also put it in the ready state if it is active. So we want to see how we can create threads in our Java applications. Every language has its own syntax of creating threads. If you go to C#, you will find that it has its own syntax. Come to C++, it has its own syntax. Java also has its own syntax. But the idea is the same. Okay? So in Java, we have a thread class. A thread class. If we want to create a multi-threaded application, then we have to inherit from this thread class. We have to inherit from this thread class. We have to extend the thread class. That is if we have to create a multi-threaded application. Okay? The other way, the second way of creating multi-threaded application is to implement runnable interface. So there are two ways in Java. Either you extend class thread, or you implement the runnable interface. Both of them will allow you to create multi-threaded applications. But the beauty of using the interface, the beauty of implementing the runnable interface is that you will have the opportunity to extend from other classes in your Java class, because Java only allows us to inherit from one class. So if you inherit from the thread class, if you extend the thread class, then you will not have an opportunity to extend other classes. And therefore, if you wanted to have an application that inherits from other classes, then you will have to separate from running, so that you have the opportunity to inherit from other classes and also implement multitasking with the runnable interface. So those are the two major ways in which we can create multi-threaded applications. So an example would be like this. Class example thread extends thread. That means we are using the thread class, and then we have run. Now, which section of code runs when you are doing a task? Everything that a thread will be doing, everything that a thread will be doing will be inside that code run. Anything you want to attend to, you have to do this run. run. It could be instantiating other classes, which is okay, but it has to sit inside the run. This is where when you start your thread, immediately you start your thread, it will go to this board. Immediately you start the thread, because you have to create a thread, start it, maybe stop it, or pause it sometime, keep it a higher priority if you want, play around with it as it becomes of money. But whatever executes is inside this code. The method patches. So creating a thread out of class, which extends of course the class. What we need to do is to instantiate an object of that class and then call start. Start will now trigger the run. Yeah. So if you say start, the code of the run method will start executing till it finishes. Once it finishes, you can either kill your thread or terminate it somewhere once it's done. Then this is the example where we are doing the run method. We implement. So you implement run and also any code that will trigger will be on the run method. The same case. So in this case, you have the also started. So anytime you, so that's the various ways in which we can create threads. This is when we are implementing the run class. That is the code. We always have the run method as a constant. And this is how you instantiate the runnable class, then start the thread. The process continues. Yeah. So we talked about shared data. Threads can access the data in the shared method section. Okay, the global data in that process. Because many threads are part of one process, they can access a global area together. And for this case, for example, this is a private integer I, and we are saying there is a potential for this variable to be accessed simultaneously by several threads because they are not local to this method. Your thread will only, anything that is inside the run method will only be local to that particular thread. But if it is the global area, then we will have to manage concurrency issues. So you will have an output. And that's why we are saying the instance fields can lead to being accessed concurrently. So there is that aspect of concurrent access of the fields. Now, and that brings us to the problems with shared data. Okay? Can potentially be shared by the thread, might be changed concurrently by multiple threads. There are no warnings. You cannot be warned when you are developing it in Eclipse or when you are developing it in Eclipse. You don't have the warnings to tell you in advance that this variable will be accessed simultaneously. So the types of data that will not be accessed simultaneously are the local variables, method parameters, and the exception handler parameters. You will not be able, those are not specific to a thread. These are specific to a thread. They are local to any particular thread. So you will not be able to worry. You don't need to worry about local variables, method parameters, exception handler parameters. You don't have to worry about those. What you need to worry is the data in the global section of your code. So, if you will have out-of-order execution when several threads are trying to access the same parameter, that is what it means. Now, how do we protect data in the shared area of our? How do we protect data in the shared section of our memory? Remember this memory space. Those are data that are here. Those are data that are in this set. This is the shared area where the main thread is. This is data that is declared around here are specific to that thread. Same as this, same as. We are only worried about this. What is there in the global area of the process. The variables, the fields that will be accessed concurrently. That is our worry. Right? So we protect fields using the keyword volatile. So if you want to synchronize access to a certain field in a Java multi-threaded application, then you use the keyword volatile. That will make this field to be synchronized every time a thread tries to access it. Yes.
What's the difference between the encapsulation and the protection?
And protection. Now encapsulation is something else. Encapsulation, you are trying to hide from access from other classes or external packages. In Java, we have packages, we have other classes, we have the subclasses. So encapsulation is you are trying to hide the access of a field from other classes. You can only access it using public members of that class. But here, two threads are trying to access one value. Because they have access. You know, they are all created
So it can be protected, but
they are all created out of the same class. Yes. They are all created out of the same class. So they know that value. Yeah. So the threads are all created out of the same. So they know that value. And besides, this value is public. So we want to make sure that only one thread can access at a time. Okay? Or rather, we want to make the thread to synchronize its working memory with the main memory. Main memory is the main thread memory section. So if I is volatile, we can make sure that it is synchronized with the value in the global area. Before the thread outputs the value, it synchronizes it with the value that is in the main memory. Because a thread will tend to have a cache of that data within itself. So before it outputs or before it saves, it synchronizes with whatever is there in the main memory. Yeah.
I thought by default, if I have a global and if I have a shared memory and a group memory, at the end of the day, after the process of everything is synchronized, why would we have to make a particular thread synchronized with the shared memory?
Yeah, this leads us to the case where we want to access. Supposing we want to access, for example, concurrency tables. Yeah, database. The concept of concurrency database, where you lock a table, either you give it an exclusive lock, exclusive read write. So in this case, we are doing the same thing but with variables. Okay? Supposing you have an array list, for example, where you put your shopping items, okay? And several threads are accessing that array list. One thread wants to remove an item, another one wants to add, or another one is reading. Okay? And we know array for an array. If I remove an item in an array, the size reduces, right? And the other thread already knew that the size is 10. Now it's 9. So you will have an exception. Array out of bounds. trying to access to reduce that type of conflict. For data that are accessed globally by several ways. Okay. So that is how to get there. We can stop a thread by using either using a dot interrupt. Okay, you can interrupt a thread. So you use the keyword interrupt. Now I want us to get the difference between volatile and synchronized. Volatile and synchronized. Volatile is used for fields, simple fields. But synchronized is used to synchronize the access of a section, several lines of code. To protect a series of lines of code. Like from this section 1, 2, 3, 4, 5. That means a thread, one thread can only access this section at a time. These lines of code. So synchronized I used to protect line 1, 2, 3, 4, 5, 6 for this case. No two threads will execute this at the same time by using the keyword synchronized. So this one is used to protect methods, for example. Yeah.
Does that mean, okay, we may have different threads running, but no more than one thread can be in that section at the same time?
Yes. So they will wait until one is done. Yes. So this section, these lines of code have been protected. So that only one thread can execute it. When it finishes, the other one comes in. When the other one finishes, another one comes in. But all other things they can do independent of each other, apart from this one. They can do other things independent of each other apart from this one. When they get here, they have to wait for each other. So this is used to protect methods, code inside methods, and volatile is used to for fields, protect fields. So that is yes. So synchronous used to create thread safe code blocks. Synchronized keyword is used to create thread safe code blocks. So you can either apply to methods. So we are saying it's similar to volatile, but only that volatile is applied to field. So threads block until they get exclusive access to that section. Blocking means they wait. They will wait until they get exclusive access to that section. Yes.
Is there a situation where I can use the volatile value inside the synchronized block?
You will not need to, because if you are inside the synchronized, you are already protected. And then we have this. So what are we protecting here? We are trying to protect a shopping list, an array list. We are trying to protect the access to an array list so that many threads will not be accessing it at the same time. So we are trying to protect synchronized add item so that when it's adding an item, only one thread can do that at a go. you are also trying to remove an item from the array list, you only allow one thread at a time by using the synchronized keyword. Same to printing the items in that array list. Okay. Remember, we have one instance of shopping cart class, and all the threads are working on that instance. So don't confuse with every thread as an instance of this. Every thread is accessing one single instance of the shopping cart. That is why we have to protect it, because it is there at the global area. Is it coming clear now? Because sometimes it's confusing. You might say, how come and I can create an object of this class per thread? That would mean that every thread has an object of shopping cart. Then we don't need to protect anything in that case. But since we are sharing the object of class shopping cart, then we need to protect access to this. Yes. So that is where the difference comes. We only protect those data that are or shared in the shared memory section. Yes.
So when I look at those functions, add item, remove, okay, each is synchronized. But I can say that one item may be adding, but another one is removing.
One item may be
A different thread may be adding an item to the list, and another one may be removing at the same time.
this one may be this one thread may call
The add item, and another one is going remove.
For now, we are only protecting the addition at the same time. We'll get to know how to protect all. Yes.
Fine.
So we'll get to executor services where we use thread rules to synchronize access to that. Okay. Then after methods, these are for methods. These are for particular section of code. Or you can protect only this section. You don't have to use synchronized at this point. So that other threads can execute up to here. Then wait for this to proceed. So you can either protect a section of code or the entire method using the keyword synchronized. Yeah. Synchronized methods use the monitor for this object. Static synchronized methods use the classes monitor. Synchronized blocks must specify which objects to lock or unlock. Okay? Because we are now doing locking here. We are locking sections of code, or we are locking methods. We are locking we are synchronizing variables or fields.
Okay.
Yes.
This is a bit of a crazy question.
Yeah.
You know, sometimes you watch movies, you see bank robberies, guys transacting, doing quick transactions.
Yeah.
And we know like most of these things are implemented with banking software and their machine.
Yeah.
Let me say, how really secure is it? With the synchronizing, can someone unsynchronize? I do not know.
But there is no unsynchronization. So it's only synchronization. And we are synchronizing access to certain objects.
Because if I know that a thread, let me say like if you're doing, maybe if you do multi-threading,
Yeah.
maybe it's single threading. It's like one thing at a time.
One thing at a
One
time.
thing at a time.
It will execute, it finish, then do another thing. It's much more like a procedure. It executes this last, line by line, step by step. But this one, there's a bit of randomness everywhere. And it is important because you want to make use of your processor time as efficient as possible. Because processors are underutilized sometimes. Because we tend to use them methodically, yet the potential they have is huge enough to solve a number of tasks. So you can stop it, your thread by checking if it is. You can also check if it is interrupted. Thread interrupted. If it is not interrupted, you can proceed to other things. Otherwise, you can automatically finish executing. Okay. So to interrupt a thread, you say interrupt. Interrupt means you want to actually close that thread, the execution of that thread. But if you say interrupt, it will not stop immediately. It will first finish what it's doing. So it might also take the next 10 milliseconds. Then now it stops. You will not kill it automatically. You're just telling it after you finish what you are doing, you can stop. So it will not kill, like it will not die just like that. Okay. So that is
Interrupt just stops the process. There's no, can you pause and restart? Which we shouldn't. For instance, if you have a thread, a process running, has multiple threads, and probably you want to pause it so that you allow
so
another
pause,
process.
you sleep.
You what?
You sleep. Instead of interrupting, you sleep. You sleep for some time. Yes.
And how is interrupt different from stop?
Stop will kill it, like crash. So it will not finish what it's doing currently. But interrupt will make it do what it's doing. When it finishes it, it exits. So yeah.
So when we interrupt, what will we wait for you to finish?
To finish execution. Maybe a certain condition has been met. If something is true, you don't really want to. Maybe you found what you're looking for. You don't want it to continue executing. So you just interrupt it. Then sleep makes it pause for some time, then it wakes up again to continue. So it will sleep for some time. So those are the major key actions you can do. You can interrupt, sleep, resume, you can also stop. Okay, so yeah, this is sleep. This one will sleep for 4 seconds. Because this is milliseconds, right? 4,000 milliseconds. It is sleep for 4 seconds, then continue with your procedures. Thread to sleep. Then you can also set a name. You can keep your threads names for better visibility. You can set the name of a thread. You can check if it's alive. You can check if it's a diamond. What's the difference between a diamond and a diamond? These are actually those processes that they are threads, but you did not create them yourself. These are threads, but you did not, it was created by other threads. So they will not stop JVM from shutting down. Java Virtual Machine can shut down while diamonds are running. But threads will, JVM will not stop until all threads are finished and sound. you can also say join, wait for another thread to finish. You can get the current thread, which you are in. Then wait, notify all threads, they go to sleep for an undetermined period of time, waiting only the object they waited for receives a record. So you can use notify, or if they was sleeping and now they are waking up.
Is there like status, check status?
Yeah, it's data, yes. So the following methods have been, you can still use them, but they are duplicated. Destroy, issue, suspend, and stop. So mostly we use interact instead of this. You can set priority. You can give your thread a priority. Giving a priority means what?
Maybe more processing long.
Yeah, more, so that the processor can give it more attention than others. Just like a process, you can set a priority of a process. Give it priority 5, priority 4. Okay? Now, in the process of doing threads, you will come across deadlocks, where several threads are trying to access objects that have been blocked by other threads. And those threads that are blocked, those objects are also trying to access other objects that have been blocked by other threads. So deadlock results when 2 or more threads are blocked forever, waiting for each other. So 2 threads are waiting for each other in this case. This one tells thread A finish, this one tells thread B to finish, so that it can continue executing. Then we have starvation. A thread can starve. When it tries to access a resource, another thread has already blocked it. Next time it tries again, another thread has blocked it. So for a long time, we say that thread is starving because it's unable to acquire the resources it's needing. It's unable to acquire the resources it needs. So we say that is starvation case. And we might need to terminate that thread if it is starving for it so that it can restart, so that the processor can give it, when we give it a higher priority, so that the processor can allocate it more attention. Yeah, and then we have live lock. Okay. Here we have a case where we have 3 threads, thread A, B, and C. For example, this is a case where thread A activates thread B, thread B activates C, and C activates A. So we have a loop, a continuous looping between non-stop. Because when thread A is activated, it activates B, which then activates C, which activates A, and then the process repeats itself forever. It's like triggers in database. There is nested triggers. It's something called nested triggers. Where a trigger triggers another one, another trigger triggers another one, then the process keeps looping. So which is not also. So we have to have a way of break. We have to have a break at some point, so that we are able to get into that lifelong situation. Yeah. So I would like us to do the exercise that is here, discuss together, we see what is happening, how our things are getting synchronized. Then we also attempt another case where we have a plan talking to a server to compute maybe a few things. Okay? Next.
Like some Toshiba, not by something called.
So HP is better.
Yeah.
10 is the best.
Yeah.
You think so?
Yeah.
HP?
It's possible. you're saying implement the same.
To extend our knowledge a bit, so that we can develop an application with a server and a client, which are able to communicate between each other. So the server would be this machine, and the client would be this machine. So they exchange data, the client gives it some data, then the server responds. So we can even create a session where they can communicate for quite a while in the process of exchanging that data. So we'll start with the server. We develop the server as a separate program, and we develop the client as a separate program, so that we can have the two communicate. Then we can exchange our IP addresses, so that your server can request for data from your client, can request the data from this server on that server, so that one server can serve as many clients as possible. Yes, it also keeps track of what exactly data the clients are sending. So we'll have one application to serve as a server, which is this. So we call it server app. So create one application, call it server app.
Should you create or on the in?
Sorry?
Should you create the server up on the in?
For purposes of your testing later,
Okay.
could you also create it? We can discuss what happens in this code. First of all, it starts by initializing fields that we'll be using. The run method is what is always important. So we are opening a network socket at port. This is the port number in the server. So all clients will contact this server at port 1800, or you can put 1200, or you can put 1300, 1400. So this is the port number. Then we say, well, true, so that we can keep listening. We can keep listening and listening and listening forever until maybe the server is shut down. So if there is a connection, we accept. Then we say we print out client accepted. Then we get the input stream, what the client is sending. After we get that, we cast it to a stream. So if it is an object that the client has sent, if it is a student object, for example, in the case of serialization, then this will be replaced with the student. Then this also student. But now we are working with a stream. We cast whatever the client has sent to a stream. Then we tokenize it with hash. Of course, we understand the format in which the client is sending this information at the server. So that's why we are using hash. So it is sent to integers. You calculate the sum. Then we use the output, object output stream to send the result back to the client. When it gets that result, we don't know what it does with it. That is where the job of the server is. This is a simple example. Maybe the server is sending data to be sent in a database server. So that is why we send the object to the student, send an order detailing what class this client is sending. Then we will save it in a database somewhere. Then we send the result back. We will send back a message that it has been received successfully. So this is what the server will do. So it will keep running. So try to run it and see if it is telling you it's listening for clients to connect.
I don't know because it's
It's called Ramana.
Within the same pocket.
Huh?
Within the same pocket.
Sure?
She did create it within the same pocket.
No.
New project.
A new project entirely. A totally new project called server app, client app. Which is meant to host a form. So we call it client app. Once you create your project, done. Step. Right click that project and package them to attach them in. So go to click the package, new, JFrame form. Click new instead of Java class, choose JFrame form, so that you can have and when your form is up, you will have something like you will have a form where you can add stuff from the toolbox. You are going to give it a name. So you have a form where you can drag in different forms. You can drag in tools. You can drag in a text box.
That's the name of it.
But also for asking about accessory.
What's the name of the what name did you give it? Client? No problem. Let's call it client.
Plan. That's called a plan. Set the layout so once it's down, we drag two text boxes that will go number 1 and number 2. Two text boxes. That will hold number 1 and
fields or text field?
Sorry?
Even text field university.
You use swing
The swing controls.
swing controls.
So I'm taking the text field.
2 text fields. Two text fields and a label for to hold the result. All what we are missing now is the code behind. When we click that button, there has to be some code that will be executed, which will send that data to the client, to the server. The server will send the result, which will then display. So that communication is what we need to set up now. And we will have it in this. Right click that button, the button you will click when you are submitting. Right click on it and go to events. Go to events. Go to mouse click. Click your button, go to events, and you move in the menu, look for mouse click, and you click on that. It will take you to a code section inside the code site. That's where we code from. So that when you click the button, what happens? Events, mouse click on mouse. Now that section that has been taken to is where this code sits. Where is code?
Void mouse click.
That code. That's where you code that. That's where we code that.
Is action performed and mouse clicked.
Use mouse click inside mouse click. He's living with the machine. for public way connecting or private way connecting.
Sorry?
While you are here,